The Chukchi Ecosystem Observatory is located 60 miles offshore from Alaska's northwest coast and consists of scientific instruments anchored to the seafloor that collect data throughout the year.
Observatory is a set of subsurface moorings that measure at very high temporal resolution, often once an hour or once every few seconds, depending on the instrument.
It just allows us to get a wealth of information that we couldn't get by traditional approaches.
Led by scientists from the University of Alaska's College of Fisheries and Ocean Science, the observatory autonomously records measurements of ocean waves, ice, temperature and salinity, light, nutrients and ocean acidification, suspended particles, phytoplankton, zooplankton, fish, and marine mammals.
We have one mooring out for 1 year, and then during that time we build a second mooring in the same way. And so then once the year has passed, we go back into the Chukchi Sea, we retrieve the mooring, and then we put the next mooring in.
We're deploying our mooring near Hannah Shoal. The Hannah Shoal region is a particularly important region for walrus. The benthic biomass that grows there is very high, so this makes it an attractive place for the walrus to go find their food in the summertime.
The observatory autonomously records measurements of ocean physics, chemistry, and biology.
We can combine our data and look at them in a very holistic fashion to be able to understand how the system is working.
We have acoustic sensors that look at zooplankton that are in the water or fish. Then there are also particle sensors that can look at what kind of particles are in the water column, how much is there. Then one mooring has PCO2, so the partial pressure of carbon dioxide, and pH, which measures the acidity of the water column. There's going to be a sediment trap, which literally traps the sediment that comes through the water column.
The mooring is giving us a better handle on how much the range of plankton biomass, the quantity of plankton is changing seasonally. It's allowing us to see how low the periods are in the winter and how high some of them are in the spring. And it's allowing us to see how they change even on a 24-hour basis. We can see that the plankton has these natural cycles where they tend to move around in the water column over the course of a day. When we get big enough data sets, we might start seeing the impact of things like ocean acidification, changes in pH, and other chemistry aspects of it that may be responsible for some more of the pattern in the system.
We're very well positioned to be able to make measurements for a very long time.
This long-term monitoring is supported by a consortium that includes the North Pacific Research Board, the Alaska Ocean Observing System, Université Laval, the University of Washington, and the University of Alaska Fairbanks.
Having long time series is critical for us to be able to understand the changes that are happening right now. The Arctic Ocean is a different ocean today than it was 20 years ago, and we expect that the Arctic Ocean that we will see in 10 and 15 years will be very different from the Arctic Ocean that we have today. So by starting these measurements now, we'll be able to track these changes forward into the future.